Excuse me. For being
Okay, please have a seat. We're going to start here. Okay, what we're going to do today is we're going to talk about we're going to talk about protons, neutrons, and electrons.
Yeah.
Why are we so slow today? Okay. Okay.
We gotta do what we gotta do.
So we're going to, please sit down. You came in late, so just sit down. What we're going to talk about today is protons, neutrons, and electrons. What I want to start with is I want you guys to go into groups, and I'll assign the groups. And then when you do that, you're going to talk about everything you know about protons, neutrons, and electrons. Okay. What I do, I'm going to also give you a packet so that you have a conversation starter. Because a conversation starter, because it's just going to help you talk about if you run out of ideas, like like it's positive and stuff, and you'll spit all that out. But then there's not a lot left to talk about sometimes. So I'm going to give you this packet so that you can kind of go off of it to talk about these items. Okay. Once it seems like the conversation is tapering away from protons, neutrons, and electrons, what I'll do is I'll hit the lights, and that's your key to just come back and sit in your chair. Okay. Then after that, we'll have a presentation, and at the end of the class, we're going to answer these.
What are we doing for the presentation?
We'll find out. Okay. At the end of the class, we're going to answer these questions. So that's a good way to practice it. Is right now when you first get it and you're in the group, you'll be answering it independently after the class is over. Okay. I'm going to count to 5 and 1. And just listen to your number, and then you'll go to your like number, okay? So this is 1, Tony. 1. 2 is 8. 3, 4, 5, 6, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2. Okay. Tony will be number 1. You'll stay there. Abe, if you want to go back there, 2 will be over there with Abe. 3 can stay right here. 4, you can go over to behind Domingo. 5 can stay right there. Come on, Domingo.
What's on Mingo's head?
Use that as a conversation starter, and when I walk around, I want to hear about protons, neutrons, and electrons. If you don't put it on. People work absent.
Shane, what?
What are you?
We have like 3 meters.
I forgot what I was.
Yeah, don't lie.
Just showed you.
Don't hate.
Just leave it out.
Pictures are not people. Shane loves me. Shane freaking loves me way more than he loves you, Brady. What are we supposed to be doing?
Use that. Ask one of those questions if you don't know talk about protons, neutrons, and electrons. So protons are what? Charge. Electrons are one charge.
You need paper?
So start talking about that. Neutrons are no charge.
Protons are positive.
Ask some of those questions, see if you can get the answers.
Can we even write on this?
No, just add, you just ask them.
I can. Don't you look like
I can't even move. That hurts.
Mister, look. Not me.
Okay, how's it going, Ian?
Yes.
Why?
Because I'm a G.
So it took right over. Oh yeah, it was, wasn't it? No, Shane, I'm gonna sit down here now.
Okay, do we need to go back to our regular activity? Well, let's work then. I want to hear you guys talk about protons, neutrons, and electrons. If I don't hear that, we're going to go back. Thank you.
Electrons are not in the nucleus.
How do you like being squeezed?
Electrons revolve around the nucleus.
Protons are attracted to
Protons
electrons.
and neutrons together are inside the nucleus. The nucleus is the center of the atom. The noble gases are, they have electrons.
Full outer shell.
Yep, they do. So they are stable.
And the neutron, what makes up the
Alkaline earth metals mixed with water usually result in bad things. AKA explosions.
And yeah.
Brady, stop acting like you're two.
Get out, Brady. Seriously, please get out. Just get up.
I actually like Brady.
I don't like Brady at all.
Yeah, you do, Wazy.
Brady.
And let's see here. Atoms are a specific type of molecule.
Huh?
Then look away.
Have no charge.
Time for this.
Brady, will you get up?
From the electron orbits. Changing the element. That would be
Is this for where? If I put this right here.
not in the nucleus. Electron. Makes proton. Positively charged proton. Negatively charged electron. Attracts protons and neutrons.
Okay,
While
first, yeah.
All the way.
kills electrons.
Just go the first place.
How far did you get?
Oh my god!
That's an electron. Keep going.
Attracts electrons. Protons.
How do you do this? Just go though.
Oh, wow. Should you smell that?
What? That's not me.
Shane, it's you. You know what's with it.
Okay, folks, let's get back to our desk.
Yeah.
Okay, I got this.
Yes, Shane.
I didn't.
Take your chair back.
Who put my chair?
This whole room.
I didn't do anything. Just because
Shane, put your chair back.
My hair.
that's not my chair. That chair belongs right there.
No, it doesn't change. Put your chair
Shane,
back.
put your shoe back.
Shane,
I throw that chair there. I literally don't know.
Shane, put your chair back.
I want to push the button.
Hey, that's not
That's
it.
tipping over. Now we're even.
I didn't ask you, Colin.
I went on dates the exact same time.
34. Okay, combo 34.
Dude, don't, no. No, you can't.
I don't know.
Okay, I need your eyes up here. You should have both chairs on, all 4 feet on the floor of your chair.
4 feet, what do you mean?
I have 4 feet.
Too much.
4 legs.
Okay, lie down here. We're gonna talk about this. Okay, so we have a periodic table here. I just want to show you the basics of it. You have a number 1 here above your H. That means you have 1 proton. Okay. Above your helium, you have a number 2. That means you have 2 protons. Above your lithium, you have 3. That means you have 3 protons. So this number on the top is always going to tell you the number of protons that you have.
It's called the atomic number.
Yeah, because and it's called that because it will tell you what atom you have. Okay, so if you have a number 1 for proton, you are always going to have a helium atom. Okay, if you have a number 2 protons, you will always, or hydrogen. If you have a number 2 protons, you will always have a helium atom. Okay. If you have a number 3 proton, you will always have a lithium atom. Okay? Now, if you change the number of neutrons, that's going to affect the weight. Now, this number down here is the average weight of all of the hydrogen atoms found in nature. So, on average, we're going to have a weight of 1.008. That means that some hydrogens have more neutrons and some have less. What the neutrons will do is they'll affect the weight of the atom. So some have here's a hydrogen atom that just has a proton. Okay, it has a weight of 1. If you have a hydrogen atom that has a neutron, you're going to have a weight 1 proton and 1 neutron. You're going to have a weight of 2. In nature, you have to go. Okay. In nature, you've got a mixture of these, and if you add up that mixture, you get 1.008. Okay. Now I want to show you something to demonstrate how neutrons affect the atom. And I said that it affects the weights. So what I'm going to do is I'm going to show you a video where normally water is 2 H's and an O. Okay. H2O. Well, on this video, we're going to watch how we have 2 H. Instead of H, we're going to use an isotope of a hydrogen. It's called deuterium. And we're going to look at the weight of deuterium, and we're going to compare how it looks to regular water. Okay? Regular water is mostly made up of regular hydrogen. Deuterium has a neutron where normal hydrogen doesn't. Okay? I'm going to show you that clip right now.
Rex, what you doing there?
I'm going to pull it.